Let's look at one of the important applications of this nested loop. We have seen in the previous video what exactly we mean by nested loops and some simple mathematical programs which are used to implement the concepts of, say, prime number generation or Armstrong number generation. But how exactly these nested loops will be practically used to generate some patterns? Basically, when I say a pattern will be of a right angle triangle. Now, right angle triangle can contain numbers, asterisks or alphabets. We have three different types of right angle triangle. The right angle triangle which I have shown is the first type of pattern. You can now mirror this particular pattern and make the second type of pattern, which is again a right aligned triangle, but there it will be right aligned right angle triangle. Now here I'll call this as a left aligned right angle triangle. This is a left aligned right angle triangle. We can have a right aligned right angle triangle where we are going to have the mirror of this horizontally. Suppose if I place a mirror exactly at this place, so this is going to mirror on the other side. So we call that as a right angle triangle which is right aligned, where all these asterisks should move on the right hand side. And then we'll have one triangle which is called as an equilateral triangle. Now the characters can be an asterisk, as I said, it can be numbers, can be alphabets, or even it can be a combination of all this. Let's look at the very first pattern which we are supposed to generate, which contain these asterisks. As I said, these are the best examples which are going to be illustrated for the nested loops. If they ask you to explain what do you mean by nested loop and put a program for illustration, probably this will be an idle program which you can use for illustration. Now, how do I go ahead and do any pattern program? When a pattern is drawn, when a pattern is given to you, first draw that particular pattern neatly and put a grid around this particular pattern. Now let me place a grid around this particular pattern. So here I'll place a grid around this particular pattern. Now this is my first row. This is my second column. This is my third column. This is my fourth column. Now, let me have even horizontal row wise 1, 2, 3 and 4. Now here I am going to take an illustration for just 4 rows. But in your exams, you are supposed to do it for n rows. If I am supposed to just generate this pattern, then probably the pattern can be done using only a set of printf statements. So at every junction of this, you will have an asterisk to be printed. So when a pattern is given to you, first draw a grid around this. Do spend some time doing analysis on this particular pattern. When you complete the analysis, then implementing that into a programming concept is much more easy. So as I said, I'm going to try this for 4 rows. So let me say n as 4 at this place. The value of n as 4 in this particular case. Right. Now, what variables am I going to use to control the rows and columns? Here, to control these rows, what I'll do is I'll use a variable called as r. And to control these columns, what I'll do is I'll use a variable called as c. On this particular asterisk pattern, I'm going to have 2 variables controlling the entire structure as r and c, where r indicate a variable which is used to set or assign the row value, and c is a variable which is called as a column variable, which is used to set a variable, set the values for columns. Right? Now, let's move on to this particular pattern. Let's try this. When r is 1, on the first row, assign a value to the variable r. So on the first row, I'll set r as 1. So here, let me take a variable r to control the rows. So initially, r is 1. Now when r is 1, from this you're supposed to start printing asterisks. So let's assume that the asterisks are printed using a variable called as c. So I'll use a variable called as c at this place. So do take a close look on this particular video so that you can understand the entire concept. If there is a small change in the pattern, then also you can carry out the same analysis. If you are going to practice, then you'll have sufficient time. But in exams, you're supposed to do it in a hurry. Since what you need to do is, you need to understand it conceptually rather than just remembering the loops. If I write the loops directly, probably the program looks to be much more simpler. So observe this. So when r is 1, how many columns am I going to print? Am I going to print all the 4 columns? No. I'm going to have only C with the value as 1. So the variable C will start with 1 and end up at 1 itself. So this variable starts C with 1 and ends up at 1 itself. So let me say C as 1 and it ends up at 1 itself. So now, as soon as I complete this particular C value, when C goes to 2 or when C is incremented to 2, am I supposed to print any operation? Am I supposed to print any characters? No. I'm supposed to get the cursor on the next line. I'm supposed to drag the cursor to the next line. So after doing this, what I need to do is, I need to say, get the cursor on new line. Get the cursor on a new line. So once you get the cursor on new line, then I'm supposed to check the value of R. So I'm supposed to change the value of R to now 2. So R is now set as 2. When R is 2, again reset the value of C from 1 and go till 2. So what are the variables which I am writing horizontally? They are the values for which variable? The variable C. And the values which I am writing vertical at this place, they are the values of R. So when R is 2, C starts with 1 and ends up at 2. So C starts with 1 and ends up at 2. After that, again I'm supposed to get the cursor next line. So do the same operation. Now, after doing this, get the cursor on the next line and then start with R value as 3. Set the value of R as 3. When R value is 3, you are supposed to reset the value of C to 1. When R is when R is 2 and C is 1, again you are supposed to print an asterisk. Sorry, this is, I'm saying this with respect to third row, that is R is 3. So when R is 3, C is 1, print an asterisk. When R is 3, C is 2, print one more asterisk. When R is 3, C is 3, print one more asterisk. When C becomes 4, don't do any operation, again get the cursor on next line. And finally, we'll set R as 4. So when R is 4, I'm saying it for the 4th row now. When R is 4, I'm supposed to again reset the value of C to 1, then make it to 2, then make it 3, then make it 4. All the times when C is changing its value, what you need to do is, you need to perform a task of printing an asterisk. When R becomes finally 5, I'll say stop this particular operation, because I've been asked to design this particular pattern for only 4 rows at this place. So I'll have 4 rows to this particular place. So I'll have these columns. This is for N, and this column is for R, and this column is for the values of C. Now, if I'm supposed to do it for more number of rows, then probably I'll have the same operation. I can continue this particular for the 5th row. So when R is 5, and again reset the value of C as 1 and go till the value 5. When R is 6, again start with this particular 1 and go till 7. And so on and so on and so on. You can continue this particular operation for N rows. Now let me summarize these values of R and C. When I did this, your R value is going to start with the value called as 1 and ends up at 4 in this case. Now, if I'm supposed to do it for more number of rows, then I can generalize this as 1 to N. Your R value goes as 1 to N. So it means that if N is 4, it ends up at 4. If N is 5, it ends up at 5. If N is 10, it ends up at 10. In general, your R will start with 1 and ends up at N number. Now, let's summarize the value of C. If you observe the first number C is always going to be starting with 1. But here, it doesn't end up with a common number for every row. When I'm at the first row, it ends up at 1. When I'm at the second row, it ends up at 2. When I'm at the third row, it ends up at 3. When I'm at the fourth row, it ends up at 4. So in general, can I say that this will always start with 1 and end up with what? End up with the value called as R. Because if you compare the value of R, that is the last number of this particular sequence. So here, this will start with 1 and end up at R. So the value of R starts with 1 and ends up at N. The value of C starts with 1 and ends up at R. I have this particular cursor moving on to the next line after every completion of this particular C. So this is how we are going to have this particular pattern. Now let's see a program which will implement this particular entire structure for us. Now let us see a program which is used to implement the pattern which we discussed. For a while, let's recopy the values which we stated in the first part. So I stated that for given n rows, your R will move from what to what? Yes, you remembered it properly. R is going to go from 1 to n. If you're not sure, you can rewind this, go back and restudy the pattern which I said. So your R is going to go from 1 to n and C is going to go from 1 to R. Now this is for given n rows at this place. So now question comes, if R is going to change from 1 to n, this is going to be a for loop. And if C is going to change from 1 to R, again this is going to be a for loop. Now will they be independent loop, will they be nested loop, or will they work one after another? They can't be independent, because for every value of R, C undergoes some changes. When R is 3, if you remembered, when R is 3, C starts with 1 and ends up at 3. When R is 4, C starts with 1 and ends up at 4. So the value of C keeps on changing for every value of R. So this confirms that this will not be an independent loop. So now if your answer is going to summarize as nested loops, question comes, which variable is going to be nested under what? Now just recollect the stuff which I stated at the beginning of this particular video, where I said the value of R changes and C also changes. If you count the number of changes, who is going to change more regularly? The change is of C more as compared to R. When R changes just one time, your C undergoes changes several times. For example, when R was 3, your C was changed for 3 times. After that, R was changed only once. When R was changed from 3 to 4, your C started changing from 1 to 4. So C undergoes a change more as compared to R. Hence, we conclude that C will be an inner loop and R will be an outer loop. So it means that the value of C was more changing as compared to R. The variable which changes more regularly will be always the innermost variable, and the variable which changes less will be always the outer variable. So here your R loop is going to be an outer loop and C loop is going to be an inner loop. Now let's see how we implement this particular code. Using this particular stuff which we stated, using these basics which we have acquired, let's start implementing this particular code. So as usual, we'll include the header files. Now here I'll have void main, and then I'll have the variables which are going to be used for this particular task. So here the variables which I'm going to use are the variable n for counting the number of rows, the variable R to count the number of rows. This is total rows, and this is going to control the rows, and the columns are controlled by variable called as C. Now the tradition of printing any pattern goes with a question that for how many rows am I supposed to do this particular task. So first what I'll do is I'll say printf how many rows. Now let me read this particular rows as scanf %d comma ampersand of n. So now I'm supposed to do this particular pattern for n rows. So I have two variables R and C, R controlling the rows and C controlling the columns at this place. So the very first thing which I'm supposed to do is I'm supposed to write the row loop, because row is going to change less as compared to columns. So the first loop which I'm going to write is a row loop for, I'll say R equals to 1, R less than equals to n, R plus plus. R starts with the value as 1, ends up at n, and it increments by 1 step, hence R plus plus. Curly bracket. Now, within this, I'm supposed to place a C loop. So now you said that C is going to again start with 1 and ends up at R. I'll say C plus plus. When C is changing its value from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on till R, what action you want to do on the screen? Would you wish to read, would you wish to print, would you wish to modify? The answer is I wish to print. Print what? Print an asterisk. So I'm supposed to print an asterisk on the screen. So here what I'll do is I'll say printf an asterisk. As soon as you complete this particular task of printing an asterisk for r times, the last block of your table, if you remember the beginning of the video, it says that at the last part, you're supposed to get the cursor next line. How do I get the cursor next line? So it means that I'm supposed to print a new line character. When I print a new line character, it will not get printed, but action will be performed. Since what I'll do is, I'll say printf /n. Now here, the operation gets completed. Now this will be the pattern. This will be the set of loops which will generate the pattern which I said. And then, as usual, get ch and end this particular code. If you wish, you can clear the screen after the variable declaration. Now let's see how this particular program works and will it generate the pattern which we say. Okay, now I'll write some memory variables at this place and the output at this particular place. Assume that I'm on the tip of this particular pattern. Memory says that I'm supposed to do it for n rows. Let's say the value of n is entered as 4. So now, once the value of n is entered, r starts with 1. 1 less than equals to 4. 1 less than equal to 4, true. So r is going to be 1. When r is 1, 1 less than equal to 4, true. True in the sense, if as per the rules of nested loop, if the outer loop is true, it will now execute the inner loop. C is 1. So the value of C starts with 1. 1 less than equal to r. R value is 1. So 1 less than equal to 1, true. If it is true, then I'll say print an asterisk on the output screen. So after printing an asterisk, the cursor moves to the next position. Go back, because after printing an asterisk, it will go back and then say C++. So when C is 2, 2 less than equal to the current value of R, C 2 less than equals to 1, 2 less than equal to 1, false. If this is false, then what action is going to be done? It will go to the printf/n. So automatically it will get the cursor on the next line. So I'll have printf/n at this place. So again go back and change now the value of r, because after printf/n you're supposed to go back and change the value of r. So now r will become what? 2. So when r is 2, again it says 2 less than equal to 4. True. True in the sense, what you need to do is you need to start again C with 1. So reset C as 1. 1 less than equals to 2. True. True in the sense, print an asterisk. After that, move to the next position. Go back. C becomes 2. 2 less than equal to 2. True. True. Print one more asterisk. Again go back. C becomes 3. So when C is 3, false, because 3 less than equal to 2 is false. In the previous case, when C was 2, 2 less than equal to 1 is false. So 3 less than equal to 2, false. False in sense, quit this particular C loop, get the cursor next line. After that, go back and change the value of r. R is now 3 in this case. When r is 3, so it says 3 less than equal to 4, true. True in the sense, C is reset with 1. When C is reset with 1, 1 less than equals to the current value of r. 1 less than equal to 3, true. True in the sense, again print an asterisk. After that, go back, C changes to 2. 2 less than equal to 3, true. True, print one more asterisk. Again go back, C is modified to 3. 3 less than equal to 3, true. Print one more asterisk. Go back, C changes to 4, false. 4 less than equal to 3, false. If it is false, then quit and get the cursor next line. Go back, R changes to 4. 4 less than equal to 4, true. If that is true, then again C starts with 1 and ends up at R. So when C is 1, print asterisk. C is 2, print asterisk. C is 3, print asterisk. Because for all these values of C, your R value is less. So C 1 less than equal to 4, true. 2 less than equal to 4, true. 3 less than equal to 4, true. C is 4. 4 less than equal to 4, true. If that is true, again print one more asterisk. When you go back, C becomes a 5, which is false. Because 5 less than equal to 4, false. Go back, R plus plus, R will now be made as 5. When R is 5, 5 less than equals to the value of n. 5 less than equals to the value of n. So 5 less than equals to the value of n is 4, false. If this is false, automatically it will quit. So we have an asterisk pattern being generated for this particular asterisk number of rows. So basically, I have tried this particular pattern with only asterisks. It is called as a left aligned right angle triangle, where R is going to control the rows and C is going to control the columns. Rewind the entire video, again have a look at the entire table which we designed. With that table, you'll be able to arrive at these loops. Always the variable which changes more is going to be the inner loop and the variable which changes less is going to be the outer loop. So practice this one more time, have a complete look and obtain the values of each and every variable and find the output. Thank you.